In a gas, a hydrogen molecule mass of 2 units and velocity 1880 meter per second collides elastically and head-on with an oxygen molecule mass 32 units and velocity 405 meter per second as illustrated in the figure. In qualitative terms, what can be stated about the subsequent motion as a result of knowing that the collision is elastic? Elastic collision means that the total kinetic energy of the system is conserved and the relative speed of approach equals the relative speed of separation. The collision is head-on. Head-on collision means that the motion of the molecules after the collision will be along the same line of motion before the collision. Using the answers to B, determine the velocity of separation of the two molecules after the collision since collision is elastic. The velocity of approach will be given by VH minus V0, and that will give us 2285 meter per second. Apply the law of conservation momentum to the collision to determine the velocity of both molecules after the collision. So before the collision, the momentum is given by mass times velocity, and the total momentum will be minus 9200 U Newton seconds. So after the collision, the total momentum is given by the mass multiplied by the velocity after collision, which is given by V sub H and V sub O. So by conservation of total momentum, the total momentum after collision is equal to the total momentum before collision. So you get this equation. So by conservation of kinetic energy, the total kinetic energy after collision will be equal to total kinetic energy before the collision. So solving these two equations, we'll get the velocity of oxygen after collision to be minus 136 meter per second, and velocity of hydrogen is minus 2421 meter per second. So the directions of both oxygen and hydrogen point to the left as indicated by the negative signs in their values.